All right, here we go. So, honestly, it might be 11.2 and a little bit of other sections. So we'll go 11.2-ish. And we're going to review matrices. And also learn about reduced row echelon form. Not nearly the amount of time I would like to spend on it because just the RREF part probably is worth spending a day or two on it, but we don't have that luxury. So I'm going to at least show you what it is, and it might help you on the SAT if you have systems, because it's a pretty convenient way to solve systems, okay? So first, you should know how to add and subtract matrices. What do you guys know about adding and subtracting matrices? Do you know any rules? Do you remember anything? So, should we review what a matrix is first?
Yes,
okay.
Mr. Gonzalez.
Anyway, so in a matrix, you're going to have entries. Let's say we have 4 of them like this, and then another 4. I didn't put anything in there, but the size of the matrix is read by the number of rows by the number of columns. So if you're looking at this setup here, how many rows do you see? 2 rows by how many columns? 4. So this matrix would be 2 by 4. So one thing we need to be able to recognize is immediately what the size of each matrix is. Are we okay doing that? Rows by columns? Okay. Adding and subtracting matrices only work if the matrix, or if the matrices are exactly the same dimensions. So for example, if I had a 2 by 4 matrix, I would not be able to add or subtract anything else but a 2 by 4 with that. Okay? If you ever see a problem where you're adding 2 different matrices that are different sizes or different dimensions, you would just write down not possible. Okay? So real quick, let's say I have A is equal to 2, 3, 1 for the first row, -2, 0, -4 for the bottom row. Let's say B is 1, -1, 5, and 2, 3, -2. If I wanted to add A and B together, how do you add matrices? Do you guys remember? Yeah, so each corresponding, instead of section, I'll say entry, but yeah, that's right. So 2 corresponds to what? To 1. So when we add, we get 3. And you just do that for each spot. So in the second column, when I add those 2 numbers together, we get 2. Next, we would have 6. And then, yep. -6. Okay, are there any questions on how to add or subtract matrices? What if I asked you to do 2A minus B? Why don't you guys try that one real quick? What is that going to look like? Right, so what do you do first? So we double A, so 4, 6, 2, -4, 0, -8. B is going to stay the same, right? Now we just subtract. So what should our final matrix be? -6, careful. Good. Seeing as how some of us make silly arithmetic errors when we're doing this, it's worth showing how to do this on the calculator, which we'll do in a minute. Okay, but are there any questions on how to do things by hand? Okay, so adding and subtracting, pretty straightforward. Got to be the same size. You just basically add or subtract each corresponding spot, and then you're done. Okay. Multiplication is a little different. In order to multiply matrices, the number of columns in the first matrix must be equal to the number of rows in the second one. Okay, so for example, let's say A is a 2 by 2 matrix. And if I wanted to do A times B, that tells me right away that B has to be how many rows? Has to be 2 by something. It doesn't matter what the number of columns is for the second matrix. Okay? As long as the number of columns in matrix A is equal to the number of rows in matrix B, or whatever letters they are, you can multiply. Okay? And you'll see why that needs to be the case. Let's start with an easy example, a 2 by 2. Let's say I have 1, 2, 0, -5, and I'm multiplying that with -1, 2, 3, and -1. Does anybody remember how to multiply matrices by hand? Yes?
Top row by first row by first column, second row by second column.
Okay, so first row by first column. What does that give us? -1 and 6. And what do I do with those values? You're close. You add them, and that tells us one of the answers. So what Ben is saying is, and by the way, you would do that first row, and you essentially distribute it to both columns. I don't know if this looks familiar or not, but your final answer then, so this is what Ben was saying, you do 1 times -1, which is -1, 2 times 3 is 6, and now you just add those results. So -1 and 6 add up to what? So 5 would be the first row, first column of my answer. Do you guys see how that lines up? So if you do first row with first column, that's your first row, first column answer. Okay? To find first row, second column, you do exactly that. So it'd be what? 1 times 2, and then 2 times -1. So when you add those up, you get 0. Is that, everybody see that? 1 and 2 is 2, 2 and -1 is -2. Add the results up, you get 0. Okay? Once you're done, now you just go on to row number 2. And you repeat the process. So now it would be what? 0, and then negative 15 is negative 15. Go on to the last column. 0 and 5 is going to add up to 5. Okay? So we multiplied a 2 by 2 with a 2 by 2. What kind of answer did I get? 2 by 2. Okay, interesting. If you can't multiply, you would just say not possible, and you would say number of columns in the first matrix does not equal number of rows in the second matrix. Okay. What if I had an extra, so just a little sidebar here, a little side work. Let's say I had the same exact scenario, 1, 2, 0, negative 5, but let's say I multiply that with negative 1, 2, and I'm going to add in a new column, let's say 3, and then 3, negative 1, let's do 1. Okay. This is a 2 by 2, this is a 2 by 3. Number of columns in the first one equal the number of rows there, so we should be able to multiply this, right? Do you guys see how we're going to get the same exact, well, not the exact same answer, but 4 out of the 6 entries will be identical to what we just did? Okay. You would do the same kind of thing. This row gets distributed to this column. You get 5. Distributed to column 2, we get 0 still. Here's the new piece. I have an extra column now, right? So I go one more time. What do I get there? 1 times 3 added with 2 times 1 is going to be 5 is correct. Okay, I'm trying not to like write out every single little step. I expect that, you know, you guys are pretty intuitive, and I think you guys can probably do some of that work in your head. If you guys want to write out everything, that's fine too. All right, what would the bottom row be? Still negative 15 and 5, but now we have this extra column here, right? So what do we get there? 0 and then minus 5 is minus 5. Again, first number times first number, second number times second number, add them up. So here's our answer. What did we end up with? What size? 2 by 3. Where do we see the 2 and the 3 up here? Yeah. Right here tells us what the answer size is going to be. So if we had a 7 by 2 and then a 2 by 12, that would be a monstrous problem that I would never ask you to do. But you'd have a 7, I forgot what numbers I said. A 7 by 12 for your answer. Does that make sense? Okay. Are there any questions on adding, subtracting, and multiplying by hand? Okay, let's review then how to put these into the calculator, because sometimes like in the homework or even on a quiz or a test, I might just give you, here are 5 matrices, A, B, C, D, E. Do all these different things with them. Add them up, multiply them, do 3A minus 2B, you know, all these different calculations. And it'd be nice to know how to program these in here so you don't have to do it by hand. Okay? So on the calculator, where could I access the matrix menu? Where is it? Yeah, the X with the minus 1 there. So if you do second, and then that X to the minus 1 button, you get to your main matrix menu. Okay, once you're in here, this is where you program, so to speak, all the matrices you want to use. So let's say I just to review, let's say I want to make this one A and this one B, okay? I would go to Edit, and then I would go ahead and change the size to what? 2 by 2. And this is a pretty intuitive thing. Now you just enter, exactly what the matrix is. So 1 and 2 in the first row, and then 0 and -5 in the second row. Okay? So now matrix A is programmed in your calculator. You can go right away to the matrix menu again. And now I would do what? Edit and create a new one into B. Also, actually in this case, we're going to do a 2 by 3. First row is -1, 2, and then 3. Bottom row is 3, -1, and 1. Okay? And obviously if we had more, like if I gave you more information, you would just put them all in there. Okay? But everyone okay with just programming them? Okay? Now you can do whatever you need to do. So in this case, I multiplied them, right? So if I go to the matrix menu, I don't go over to edit anymore. I just hit enter on the one I want to use. So if I want to do A times B, I would hit enter on A, and it pastes it right onto the home screen. And then I do times, and I go back to the matrix menu. And now I just highlight or select B, and there we go. Okay. Everyone okay with that?
Yes, Mr. Gonzalez.
I may have to re-record in my other class. Okay. So if I ask you to add, you guys can handle that in the calculator. It's the same steps, program them, and then just add them up. Okay. I can tell by Danny's cell phone light lighting up his face that we should move on because he is bored. So real quick, why don't you guys take a minute or two and just solve this system, okay? A review from what we've been doing. 2x plus 5y equals 8. Let's see. You guys make up the rest so that it's. Give me another equation. Pick any number to start with. 3. And now give me a number to go up or down by. Up 4, I heard first. Okay, so take a minute or two and solve. Solve it. Yeah, find x and y. Nope, you can do it however you want. Based on the numbers you guys gave me, you should have some pretty nice answers. Anybody have them? What do we get? Correct. Okay. Now, how did you guys approach this? What method did you use? Some substitution, some elimination. Fine. Let me show you something here. Okay. There's actually a couple ways. There's actually a couple ways that you can use matrices to solve this for you. I'm going to show you what I think is the fastest and most efficient way. And again, if I had more time, I would actually explain more of how to do it by hand and what the calculator is doing. But here's what we're going to do. Okay. We're going to create what we call an augmented matrix, which is essentially two matrices in one. Okay? So if I looked, just looking at this, how many rows do you see? Two. And how many columns? Three. So we're going to call this matrix a 2 by 3 matrix. And we're going to go 2, 5, and the calculator won't show us this, but really what we're doing is a 2 by 2 kind of combined with this column over here. Here we'll have 8 and 11, okay? And then down here we'll have 3 and 7, okay? So if you guys saw this matrix, would you be able to understand that this represents 2x plus 5y equals 8, 3x plus 7y equals 11? Okay. Go ahead and program this matrix in your calculator real quick. Okay? You don't have to do anything special. I know it's called an augmented matrix, but you just go in there and make a 2 by 3 and then put in the numbers like normal. You can just overwrite. If you're using A, you can just overwrite it and change the dimensions and then put in the new values. No. You don't have to worry about that. So I'm putting it into matrix A. Two, 5, 8, and then 3, 7, 11. Has everybody got theirs programmed in there? Yeah. Okay. Go to the home screen. So quit. And now if you go to matrix, the only menu we have yet to talk about is this middle one, the math menu. If you go over here, you're going to see all these cool things that you can do with matrices, okay? But we're going to scroll down and find the one that says RREF, which stands for Reduced Row Echelon Form, okay? RREF, okay? Now, if I select that, now the calculator wants to know, all right, which matrix do you wish to, put in this format? So now I would go back to the matrix menu and hit enter on matrix A, and then all of a sudden, we have this new nifty matrix that's the same as the one we started with, just reduced in a certain way. Do you guys see what I'm talking about? If I translate this to an equation, what does this mean? X, basically x equals -1 because there's no y's, and then y equals 2. Does that make sense? Okay. This is by far the fastest way to solve systems. I mean, if they're easy, you can do them by hand, but maybe on the SAT or whatever, if you see a system and you're like, man, I don't want to solve that, that's going to take me a couple minutes. This will do it in 10 seconds if you know how to program it. Okay? Not only does it do 2 by 2s, but if you go in here and if we have a 3 by 3 equation, like 3x plus y plus z equals 9, this is going to probably have ugly answers because I'm just making them up. X minus y minus z equals 2. And then let's say 5x plus 10y plus 2z equals 5. Okay? How would I program this matrix into your calculator? It's a 3 by 3 on this side, but remember we have the answer column, so it's 3 by 4, right? Very carefully go ahead and put in the coefficients. So 3, 1, 1, and 9. 1, -1, -1 and 2, 5, 10, 2 and 5. Okay, and once you're done with that, you repeat the calculation. And like I said, it was, oh, that's actually not too bad. Okay, so what does this mean? X equals 2 3/4, right? This would be y is whatever that fraction is. And then this is your z, your new variable. Okay, so pretty nifty because it does it really fast for you. And let's say you want exact answers. How do I get fractions on here? Yeah, you can still do this even with matrices. And so now there are your exact answers if you needed them. Okay? It's math in the very first option. Okay? Are there any questions on this?